let us continue with the basics. And again, what do I mean by basics? API basics, of course. So APIs are sets of reusable operations. These operations are often related. Okay. These sets of operations are there to expose and manage data. They're there to manage a business process. They're there to integrate applications and so on. That's the main purpose. Every single one of those API operations has a name. That's the operation name, which is the basic unit of an API. It has inputs. It has outputs. And of course, these inputs and outputs are of a specific data type. So provided you pass the appropriate, the correct inputs, you're going to get the corresponding output. Okay? So that's what an API is. An operation with inputs of a specific type that processes those inputs and gives you the corresponding output. Nothing else. That's it. That's where it begins, that's where it ends. Okay, those of you who have programming experience, you know what a procedure is, you know what a method is, you know what a subroutine is. That's exactly it. You invoke it by providing the name, the operation name, the input, the output, and then you get the output, right? The input must be of the right type, and then you get the output. I can even give you another analogy. A lot of us have used Excel. A lot of us have done a summation of a particular range of cells, a column. That summation is a function in Excel. You can type it in, you can say sum, you can open parentheses. Inside the parentheses, you can go and provide the range. And if everything checks out, that is, the range contains only numbers, numerals, then you can go ahead and get the summation of that range. You can extrapolate. An API is no different, right? It has a name, you provide the inputs, get the output. The difference is that it doesn't reside inside an Excel spreadsheet. It's not self-contained within an Excel spreadsheet or any spreadsheet. It resides over the internet, right? The actual code that needs to execute resides into the internet. So what you need to do is you need to package your inputs in a specific manner, communicate that set of data over the internet to that location that contains the operation, execute the operation, package the output, the response, so that it's able to be returned using the internet back to the user who invoked it. That's how modern APIs behave over the internet. But again, they're pretty straightforward. There's an operation that has a name. It takes inputs. And if you provide the right inputs, the right data types, right, integers, numbers, strings, and so on, arrays, etc., you're going to get the corresponding outputs. That's where it begins, that's where it ends. And APIs exist from way back. Between the 40s and the 70s, they were in the form of a punch card. You write your code, you store it in a punch card, you want to reuse it, you go ahead and load it up. In fact, from the moment you had a function, the concept of a function, a subroutine, a procedure in a programming language, well, you got APIs. In fact, the term was coined almost 50 years ago, 1974, for the very first time. So if it was coined for the very first time in 1974, then they existed from way before that. In the 80s, and this is pretty much the very first form of APIs that I got exposed to, they used to be in the form of files. Everything was packaged together in files, and those files have a specific extension, .a archive, .so shared object, .dll dynamic link library, .jar Java archive, and there's more. There's more. This is not the only ones. There are more of these types of files that get packaged together. And of course, what do you need to do? You need to copy that file now in the appropriate location that you as a developer, as another developer, write your code so you can go ahead and use it. And again, don't lose track. APIs are built by developers for developers. Always keep that in mind. API is not something that's usually used by a user directly. It's not done that way. APIs are used through some kind of a front end, a user interface, your browser and so on. So that's how they're used. So APIs built by developers for developers. And those other developers that are using those APIs, they're using it because they're solving one or part of the problem, part of the problem, in order to build the next great feature. And that provides efficiencies to developers. In the mid-90s, you had Corba and DCOM, which is the very first time we were able to make calls over the network, right? Over the network. You use APIs that resides over the network. We used to use the network before that. Don't get me wrong, right? We used to use the network before that. But that was the first time that we had something that was standardized. Thankfully, they died very quickly because they were overly complex. In the late 90s, you have XML-RPC and SOAP. Why did we get these in the late 90s? Because the HTTP 1.1 protocol was first defined in 1986. Was first defined in 1986. And of course, the HTTP 1.1 protocol was defined primarily to communicate HTML pages, right? Go over the network, fetch an HTML page, render it on your browser, and so on. But it didn't take very long before people realized, hey, I can start using the same exact protocol, the same exact methodology. I don't want to call it methodology, the same exact, protocol, the HTTP 1.1 protocol, to communicate structured data that just contains data for my own purpose. I don't know, customers, flights, accounts, and so on. So it didn't take very long. That's why you see 98 XML-RPC. That's why you see 99 SOAP. All right, that's why you see in the 2000 RESTful, JSON-RPC 2005. RPC stands for Remote Procedural Call. All right, keep that in mind. We're going to revisit later on. In 2010s, you have GraphQL, 2012 in particular. Right? And GraphQL is great primarily because it makes it easier for the user to use APIs. Makes it a lot easier for a user as compared to any other format. Makes it a lot easier. And I think it is the next biggest great thing that is out there. And tons of vendors are choosing to build GraphQL APIs, right? As compared to the next one, gRPC. gRPC is still an RPC style. Yes, it makes things a little easier. Yes, it makes use HTTP 2.0. It makes things a little less complex when you're communicating data, but it's not from the user's perspective. It's from the actual producer's perspective and implementation perspective. It makes things a little faster for sure, right? But GraphQL makes things easier for the user. And why am I focusing on the user? Because, my good people, there is a single industry standard that measures API success, right? What is that industry standard metric that measures API success? That's usage. The more users you have, the more successful your API is. Consider this. Consider you build an API. It took you 2 months to build the API. Nobody's using that API. Well, you just wasted 2 months. If on the other hand you have hundreds, if not thousands of users, well, guess what? You have a very successful API. And in 2010s, we also have specification languages. What the heck is a specification language, you may wonder? It's a formal description of these operations, the inputs and the outputs. That's what they are. And this was a critical junction in the adoption of APIs, right? That was a very important, it was a pivotal point, right? In the adoption of RESTful APIs in particular, right? Why? Because now I had a way to describe all the different operations that are provided. So now, if I'm building something that is formal, that means it's machine readable, right? And the best practice says this specification should be both machine and human readable, right? That's what the best practice says. This is where SOAP failed. SOAP provided specifications for the SOAP APIs, but they were not human readable. They were only machine readable. I'll show it to you in due course. So as soon as you get this Open API specification or RAML, RESTful API Modeling Language, guess what? RESTful APIs exploded, and even to this day, RESTful APIs is the most common form of a modern API that you're going to see out there. We have tons of legacy though, right? Tons of legacy. There's tons of SOAP. But for the most part, all new development is done using RESTful APIs because it's simpler, as I will demonstrate later on. So if you have these specification languages that describe those operations in a formal manner, guess what? I can build tools to facilitate their adoption, their use. I can build tools to create a presentation layer for those APIs and so on. Tons of things that can happen. And if you're wondering where do you gain access to those APIs, well, vendors. So yeah, you can integrate with those tools in an enterprise setting, right? Again, you buy an enterprise application, any modern organization that buys enterprise application expect them to communicate with the rest of their ecosystem. Well, that's the premier way to do these integrations using APIs. Open source projects, tons of them. Your colleagues in developer teams, right? So they build their own set of APIs to facilitate, I don't know, the next greatest feature and so on. And if you don't believe me, go to Wikipedia, right? You'll see exactly what I'm mentioning right here. So what are the different components of a modern HTTP-based API? I will tell you that the very first time I started building APIs, and for the longest time, the only thing you cared about was the implementation. That's it. You had the implementation, you provide it to the different users, you may be going to provide some rudimentary documentation to explain what these operations, the inputs and the outputs are, but those will get out of sync very quickly, right? It wasn't very well thought out. Let's put it this way. Eventually, we decided to provide interfaces. That's a different nomenclature for specification. And yet another nomenclature for both interface and specifications called the contract. Right? That was the contract between the user of the API and the producer of the API, the owner of the API. The owner of the API explains using a formal document, this interface, what are the operations, the inputs and the outputs, right? It could be OpenAPI specification, it could be RAML and so on, right? And if now myself, as the user of an API that potentially you have built, right? Now I wouldn't have to be on the phone with you or exchanging emails or being in Slack or Microsoft Teams all the time asking you questions. How can I use your APIs? Right? I will have something that will help me run PUP on my own how to use the API so that I can save you time to go and build the next version of this API or the next API and so on. See how efficiencies are built if you provide appropriate and accurate documentation with respect to your APIs, right? And again, I'm mentioning just the OpenAPI specification in RAML because this is what currently being used for the most part. SOAP had its own version of a specification, but it's overly complex, as I will show you soon enough when we go inside and we see PayPal's SOAP APIs, right? Overly complex, non-human readable. You need tools. You pretty much need to be a developer to understand everything that takes place, right? So, implementation, all days. Nowadays, you get the implementation, you get the associated interface, and you have something called the API gateway or the reverse proxy. And if you have this type of technology, and I can guarantee you that best practice, and most of you guys, your development organizations employ these API gateways, or also known as reverse proxies. So your users don't go directly to your implementation, to your actual API. They use another step. And it is this step that governs access, controls access. They may contain an implementation. They may contain an implementation with respect to um, authentication, authorization, who can access the implementation, and so on. And why do you want to split all that stuff in two separate uh, I don't know, items? The implementation and the reverse proxy. Why do you need this reverse proxy? Well, there's a concept called functional and non-functional requirements. A functional requirement is actually solving the problem you're trying to solve. For example, if I want to build an API that retrieves customers, well, I'm actually building the code that retrieves the actual customers. A non-functional requirement is when I'm trying to authenticate, when I'm using logging, when I'm using caching, right? Performance tuning, all those things are non-functional aspects of an application. And guess what? These non-functional aspects, they keep repeating irrespective of which application, of which API you're dealing with. So does it make sense to implement it once and keep reusing it? It does, right? So that's exactly what we refer to when we say non-functional aspects of an application or non-functional requirements. Anything that is necessary for any application, even APIs. APIs is a form of a software application, right? Anything that is necessary for the application to operate securely, safely, and normally, that is not related with actually the solving the use case that you build this application for, right? Authentication, authorization, or the aspects that keep repeating, right? Authorization, authentication, they always keep repeating. Logging, they always keep repeating. Implement it once, keep reusing it. So the ideal location to do that is inside an API gateway, also known as reverse proxy. And these are the main aspects of a modern API, the main components of a modern API. And with this, my good people, we completed this basics section. Talk to you in the next one.